Greetings and salutations. Greg here, back at ya with more of the hardest math problems. Show your work section. We're on part B of the first section of the grade 7 show your work questions. Check out the link, GregsTutoringNYC.com/hardest-math for the whole series. There's dozens of videos for all grade levels. There's also a multiple choice section. Yeah! All right, so let's jump right into this. I did part A with 2 constant proportionality questions. Let me make sure I'm getting rid of that. Give me 1 second. Okay, there we go. Okay, so let's jump into this. Yeah, hooray. It's a word problem strictly. Harper has $15 to spend at the grocery. Hey, great. She is going to buy bags of fruit that cost $4.75 each and 1 box of crackers that cost $3.50. Okay? Write and solve an equation. An inequality. So this is something in particular that models this situation and could be used to determine the maximum number of bags of fruit, B. Okay, so we're trying to look for B, the number of bags. We can go check the answer again. We're looking for a count. Okay, we're trying to look for a count. So you just can't jump into this. It says for you to write an inequality. Okay, you just can't write an expression, and you can't write an equation either. You have to write something, at least at this grade level, with the less than, a less than or equal to, a greater than, or a greater than or equal to. Technically, there's also a not equal to, but that's just not going to apply in this example. Okay, and again, we're not using equal at all either. So these two are not considerations. We're trying to use one of these 4 to try to capture what's going on here. All right, so kind of think it through. How would you do the comparison to be able to kind of get that thing? Okay, so she has $15 altogether. Okay, and it's asking for the max. So that means the number of bags should be smaller. So the dollar amount has to be greater than, and it could be equal to, right? $4.75 per bag, and B is the number of bags. And she also spends $3.50 on a box of crackers. All right? So to me, that maps straight into that. Okay? Okay? If she buys 1 box of crackers, that's $4.75, plus she buys that's $3.50, and she buys 1 bag of fruit, right? So she buys 1 bag of fruit, that's $4.75, right? And then you have to add the $3.50 for the crackers, right? So we get 5, 2, we get $8.25 for 1, right? If she bought 10 bags of fruit, that's $47.50 plus the $3.50, right? That's $51 if I'm doing that right. I'm doing that really quick. I'm just estimating this to kind of show the point. All right. In this scenario here, she doesn't have enough money. That's not what this question's about then. This is about the scenario where she has less. All right. Because they want to know what's the most amount of fruit she can get without going over $15. All right. So that's why the inequality is structured this way. And by the way, we could flip it. Let me change the color to make that a little clearer. Because there's an alternate way, which is that the 4.75b plus the 350 is less than or equal to 15. That also works. And for both of these, if I call this A and this B, it doesn't matter what order we put this in, because we could have also said 3.50 plus 4.75b is less than or equal to 15. We could have done that over here as well. We could have said 15 is greater than or equal to 3.50 plus 4.75b. Okay, those are all, so we have number 1 here, number 2 here, number 3 here, and number 4 here. These are all valid equations to solve this. There's actually other ones too, but they want you to stop from here because that maps the English straight into that. So write and now solve it. So now we need to solve it as the second step. Okay? And if you notice, it says could be used to determine. So there can be other solutions to this. You could guess, but if you guessed, you're not going to get the full credit for solving this problem. It's asking you to write the inequality, right? So you might guess or use another strategy. They're asking you must solve this algebraically with an inequality. All right? All right, so let me kind of do that to give us a clean slate. So let me just go with the first one. 15 is greater than or equal to 4.75b, because now we're going to solve this, plus 350. We're going to subtract 350 from both sides. Okay, that cancels out. And we're going to get what? Is that 1150? In other words, 15 minus the 350 is 1150 is greater than or equal to 4.75b. Okay? Whoops, greater than or equal to 1114. Yep, it's 1150. And now what we need to do is divide both sides by the 4.75. Okay, so that's going to cancel out. So we have b is less than or equal to, let me write this cleaner. Okay, so we need to do this division right here. So if we set it up, that 4.75 divides into 11.5, right? Okay, and some of you might leap out with the answers already. We want to get an integer on the outside of here, so we're going to move this decimal point 2 places. What we do on the outside, we do on the inside. So basically our actual division is 475 into 1150. Okay, 475 into 1, can't do. 475 into 11, can't do. 475 into 115, can't do. 475 into here, well, if it was times 3, we already know 400 times 3 is 1200. So we know the answer has to be 2. All right, at this point, we get 950 is what we're going to subtract from there. Whatever this is here, it means we get 950 dot something, either a decimal or a fraction. Okay, so we can stop as soon as we get to 2, because it says what's the maximum number of bags. Okay, we're not looking for 2 point whatever bags, so the answer would be 2. We're done with the problem at that point. Okay. Okay. I mean, you can go and compute that number, but it's not really going to help you. So as soon as you know you get that, then you're cool. All right. I mean, we could have dropped down to 0 here. What did I say? That was 950. From that would have given us 200 and dropped down to 0. Right. So we got the 4 thing here into 2000. Times 5 is already 2000. So times 4. 16, 17, yeah, 4 would work there. And then there would be a remainder. We would end up with 2.4. But that 0.4 doesn't help you. All right? So this was about algebra. It involved multiplication and division, obviously. It was a word question. It obviously involved inequations. Okay? And by the way, this form that I drew for each of these, what the 1, 2, 3, 4 here, the 1, 2, 3, 4. These are all modeling the equation of a line. Okay, that's y equals mx plus b, for those who know what that means, or if you don't, you can go look it up. This m here is normally called the slope. Okay? In this case, the slope, if you go back to the part A of this thing, the other two questions I solved initially, this slope is your constant of proportionality. It's a constant. That's true across all forms of that line. B is the y-intercept, which means the line is moving up and down. Okay? And we can use this to model a whole bunch of things. So the equation of a line, which is also called the linear equation, it also includes the constant of proportionality, right? So this bugger shows up a lot, and even though you may not have learned yet y equals mx plus b and so on, this is still a notion you need to be ingrained about, okay? All right, so that's 57. I already did 59. This is 60, another word question. Members of a baseball team raise $967.50. That looks like an ugly number, but let's see. To go to a tournament. They rented a bus for $450 and budgeted this per player for meals. You can almost write this out. This looks similar to what we just did in the other question. They will spend all the money. All right. In the previous example, she could only go up to the other thing. Here, they're going to spend it all. Again, write an equation and then solve it. Okay. In this case, we have an equation, so it must have an equal sign. Okay. It must have an equal sign. So what we're going to have is the total, the 967.50, the total is going to be equal to the different parts that we had involved in the question. It's going to be $28.75 per player, okay, plus the $450 for the bus. If you notice, this again is the y equals mx plus b form. So this turns out to also be a linear equation, and this 27.75 is our constant of proportionality again. And it makes sense. Each player is going to be paying, or it's going to cost each player the same amount of money, right? So what we're trying to do is figure out the number of players that were involved. This isn't changing. That is not changing. Okay, and that's $450, not $4.50. And then what we can do is figure that out to map all that into things. So this is one way to write an equation that they're asking us for. Now they're asking us to solve it. Okay, so we can subtract 450 from both sides. That cancels out. Subtract 450 from here. So we get 50 there, .725, if I did that correctly. That should be a 1, I think, right? Yeah, I think so. So now we have that is equal to 2875p, and now we're just left with this ugly numbers to argue with. 28.75, that cancels out. And then what we did on the one side, we have to do the other side. 28.75. Before I actually do that ugly division, I want to make sure I put the numbers right. I have dyslexia and other related issues, so I just want to make sure I'm copying of 967.50. They rented a bus for $450. It was $28.75 per player. Cool. I subtracted $450 from both sides and then divided by that. 967.5 minus 450. That's going to give us 50 there. 517.50, right? So now I'm going to take 28.75 and divide it into 517.50. I don't want to use a decimal number on the outside, so I move that twice. I'm going to move this twice, so let's write that clean. We have 28.75 goes into 51750. This looks ugly for certain. For certain. Okay, so 2875 into 5, no. 2875 into 51, no. 2875 into 517, no. 2875 into 5175, can it go twice? No, that's 50. If it was 2800 times, so that's already 5600, so no. So it goes once. This is 2875. Let's see, that's 0, that's 0. That's 4, that's 1, 8, 9, 10, 11, that's 3. 4, that's 2300. So that's cool, it's lower. I'm going to drop down to 0. So let's see. If it was 2875 times 10, I would get 28,000. If it was 2875 times 7, the last digit would have to be a 5. So this is either times 6 or times 8. Times 6, let's see, if it was times 6, if I round this up to 3,000, it would be giving me about 18,000, so that looks too small. Okay, and if it was 3,000 times 8, that's 24. So 8 looks like what it is. So let's test 8. 8 times 5 is 40, 0, carry the 4. 56 plus 4 is 60, 0, carry the 6. 8 times 8 is 64, plus that is 70, 0, 7. 16, 23, oh yeah. All right, so the answer is 18 players. Okay, let's double check that. Let me change the color. I want to make sure I did the division correctly. So if I have 2875 times 18, I'm trying to get the 5750 back. In fact, at this point, I can bring the decimal point back because I'm looking for originally. I'm not looking for 51,000 whatever. I'm looking for $517.50. So 8 times 5 is 40. 0, comma my 4. 8 times 7 is 56. Plus that is 0 gives me 6. 64 plus that 0, 7. Oh, actually, I just computed this. 16, that's 23,000. And then I'm going to add 5, 7, 8, 2, 0, 5, 7, 1, 1, 5. Move over 2 decimal places. Move over 2 decimal places, and I get back to 517.50. Yeah! Awesome. Okay? I can change the color slightly because I'm going to just explore deeper again. We originally said this was the equation. Okay? What you could have done was observed that we were going to do that subtraction. So we could have done 976.50 minus 450. And you could have also observed that you were going to do the division. 28.75 is equal to P. Now, if you notice, it said write an equation that could be used to determine P. So it didn't say the equation had to be P equals. But if you think that way, because everybody thinks differently, this is an alternate expression that they would have accepted as one of the possible answers. Okay? And they also would have accepted it where if you had 967.50 minus 450 equals 2875p. Okay, as long as you use p in the right context, it makes sense, right? And if you think about this purple one, that's easier for some of you to understand. The 967 was all the money that they ended up having. Okay, 450 is the bus. So that's not a per player thing. That was a constant thing they had to throw into there. All right. So if we take the bus money out of the total money they raised, we're left with the money that was raised per player for the cost of their meals, right? So if we divide that by the 2875, which is the cost per meal per player, we end up getting the number of players. Voila. So we're still going to get the 18. All the other divisions and stuff that I did, they'll be exactly the same. So this fuchsia color is only to point out that that would happen. So this is a word question. It involved multiple steps. It involved algebra, it involved an equation, it involved division, it involved multiplication. Yeah, all right? And it involved the constant of proportionality in the form of a linear equation. All right, so that's 60. So 18 was the answer. Okay, we're now into a different kind of a question, a horse of a different color, if you will. Again, it's a word problem, though. Last week, Rachel power walked 2 3/4 miles per day. Okay, on each of 7 days. So last week, every day that week, that's what this last part's smacking us in the face with. Every day that week, she did 2 3/5 a mile per day. Okay, so we're up to here. So during the same week, when? Last week, okay, she also jogged 5 3/4 miles per day on only 4 of them. Okay, so let's be clear. For 7 days, she walked 2 3/5. Okay, and 4 of those that same week, not a different week, she jogged 5 3/4. And this notion where I'm writing stuff down, I'm doing this for myself, although it's a model that you guys should be following as well. And then finally, we're up to here. What was the total? In other words, when you can draw and write things down, visualize it on paper. What was the total number of miles she walked and jogged? Well, this is the walked line here, and this is the jog line. So let's figure this out. We have 2 3/5 times 7. Okay. And for this, we're going to have 5 3/4 times 4. And then when we get the both of those, we're going to add them up to get the total. Okay, that's what it's asking. What is the total number of miles that she walked, right? And these are in miles. So let's go for this. This is the same as 10 13/5 times 7. 7 is the same as 7 over 1. And that's equal to 70 91/5. Okay, and that's equal to, what is that equal to? Something doesn't go straight in. 1850, yep, 18 and 1/5. Let me just double check that. 50, 90, yep, 18 and 1/5. And for this, we're going to do 5 3/4, so that's 20 3/4 times 4, which is 4 over 1. The 4's cancel out. We don't need to do 23 times 4, and we get 23. Okay, this is miles, 18 and 1/5 mile, and 23 miles. So as I said, we just need to add them up to get the total. All right, so the 1/5 carries down. 8 plus 3 is 1, 1. So we get 41 and 1/5. Give me 1 second. I just want to check all the numbers again, because these are, attention to detail is important, especially when I have dyslexia. So 2 3/5 for 7 days, yeah. 5 3/4 for 4 days, yeah. So that's 10 13/5 times 7, 70, 91/5, 18, cool. And the other was 5 3/4, yes. 23/4, cancel, 23, good, okay. 18, 23, 33, 41, and 1/5, okay. I'm going to show another way to do this using decimals. So 2 3/5 is equal to, and by the way, the answer allowed here was 41.2, Because 1/5 is the same as 20 hundredths, okay? Or 2/10 if you will, okay? So this is the same as 2.6, right? That's 6/10. So if we multiply that by 7, we get 2, 4, 14, 18, all right? And move the decimal. We have one thing here, so we move it there, okay? That's 18.2. That is what 18 1/5 is. That's 18.2. So that checks. And then 5 3/4 is equal to 5.75. And we're going to multiply that by 4. You can double this twice or multiply it by 4, right? So let's multiply it by 4. 5 times 4 is 20, carry the 2, 28, 0, 2. And 5 times 4 is 20, 22. 23, sorry. I did that wrong. Wait, 5 times 0 is 4, carry the 2, 28, 0, carry the 3, okay? And then get 23, yeah. Okay? If 4 is 2 times 2, what we could have done was double this and gotten 10, 11, 50, and double that again and gotten to 23 the same way. These are both, in this scenario, they're both fairly easy to do. So notice we get to 23 back, which was the original number we had over here when doing it. So this is a word problem. This involves multiplication. It involves mixed numbers. It involves fractions, right? So there's a lot going on here. It involves combination. This is about just plain old arithmetic operations and making sure we kind of have our A game on and that we're kind of making sense out of this stuff. All right? And it could be done with fractions or with decimals. And therefore, if you do the conversion, it's about conversion to decimals. In fact, if you use decimals and got 41.2 as your answer, right? Because we would have added the 23 plus the 18.2 and gotten 41.2. It could have said, what's the answer as a fraction? And we could have mapped that back to 41 2/10, and that cancels out to be 1/5, right? And y'all lived happily ever after. Yeah. All right, I think we have one more question. Let me see here. And again, it was in miles. We want to confirm that's what we were doing. We added the 2 3/5 miles times the 7 to get the 18 1/5. We did the 5 3/4 times the 4 to get 23 miles. And then we added the miles together to get the total miles. Okay, we did 62, yeah. And let me see here. Yeah, this is the last question. Okay, so we have a word question. I kind of like these bullet ones. And let's see how we're going here. So a scientist uses submarine cool to study ocean life. Cool. Okay. What we can do is take these in a linear fashion and just see what's going on. So she begins at sea level. So like I was saying earlier, we're gonna write stuff down, which is 0 feet. Okay. Okay. So we're here. We did that. She travels straight down, going at 90 seconds for 90 seconds. At the rate, right, of 3.5 feet per second. Okay, this is a rate question. Distance equals the rate times the time. Okay, we know that she was going at 3.5 feet per second, per 1 second, right? Times 90 seconds. Okay, our unit cancels. So what we have is we're left with feet. That makes sense because this is the distance. So now what we need to do is 90 times 3.5. Okay, that's 0. We get 45. That's 0, and we get 27. That's 0, 5, 1. I believe that's 31.5, is that? No, sorry, it's 315. Because we have one decimal over here, we move one decimal there. So that's 315 feet minus, she's going down, okay? And we can just double check this multiplication by flipping it. Normally this is the easy way because the zero's there. So that's a 0, 9 times 5 is 45, 4, 27, 28, 29, 30, 31, okay? So and again, we have the, it was 3.5 times 90. We move one decimal, we go over one decimal, right? So she went down. So now we're right here, all right? She's not at sea level anymore. She's 315 feet negative from sea level, okay? Now we're going to come to here. She then travels directly up. So let me change the color of this. So she's down here and she's going to go directly up. I'm going to move that to the side, even though it should be here. For this, she was going 30 seconds. At, what does that say? 2.2 feet per second. Okay? So what we need to find is how far did she go up? We're still going to use the same formula, right? So distance is equal to rate times the time. The rate is 2.2 feet per second per 1 second times 30 seconds. The seconds cancel out. We're left with feet. 3 times 2 is 6. 2.2 times 3 is 6.6 times the 10. It's not 3, it's that. So we get 66. So she goes up 66 things there, right? So we have minus 315 plus 66. So now where does she end up here, all right? So what we need to do is figure out that out, and we do reverse subtraction at that point. So if we do 315 minus 66, okay, we need to borrow, so that take it from here. That's 9, and this is obviously 24. So she's at this point at minus 249 feet. All right? And before I continue, let me just double check all this to see if I have my head screwed on right and I did all these calculations right. Again, this is what you guys should do. She begins at sea level 0. Cool. She travels down 90 seconds at 3.5. So what do we do for that? We did 3.5 times 90. Anyway, that's 270 plus 45. 270 plus 45 is what? 331. 31 plus the half, right? Okay, there we go. We got 315 then. And then she goes back up. 30 seconds, that's 66. So that brings me here. Let me just double check. 249 plus 66 is 5113. Yep, okay, we did that all that right. So she is, and then it says, so we're here, okay? After this 120 seconds, which this 90 plus 30, in other words, when she went down and back up, okay, took her 120 seconds. After that, how much time will it take the scientist to travel back to sea level at 4.8 feet per second? Okay, so let's solve that up here. Well, if D equals RT, and it's asking us, where are we? How much time will it take? If we divide both sides by R, this cancels out. So that means T is equal to D, whoops, over R, okay? We know our distance is here, the minus 249. And the rate they give us here is the 4.8 feet per second. Okay, and it's going to ask us how long. Okay, you can all see that we're going to get a negative answer. So this was similar to the example that I gave before. We really want to be taking the absolute value of this. All right, so we're going to divide 4.8 into the 249. Okay, you don't want to do decimal on the outside. You move that over. So we get 48. And it means we had to move one over and add a 0 there. Into 2490. And hopefully this gives a clean number. I'm going to pull off the screen. Let's see here. If it was times 10, I would get 4,800. That 2490 looks about half. So it's either 5 or 4. We can't really go by that. 2004, yeah, I think it's 5, yeah. So if I multiply that by 5, I get 0.4. I get 24, right? Okay. So that's 2,400. We get 90. That drops down. That can't go twice, it'll overflow it. So it goes into one time. All right, and I'm going to pull up the screen. If we had a 0 there, we could carry that through as well. And we could probably figure out that answer. It actually adds to the nearest tenth of the second. Okay, so in that case, let me redo that over here so we can fit on the screen. 48 goes into 2490.00. So we said this was 5. That gave us 240. We get 90. Okay. We can't go in twice, it can only go once. So we get 90 minus 48. Let me erase this here because we don't really need this at this point so that we can continue this on the side here. Okay, so 48. We do that subtraction. What do we get? 42. Yep. I'm going to drop down that 0. Add the decimal point. So this 48 goes into here 8 times. Let's try that on the side. 48 times 8. 64, 6. 32, 38. Is there enough space to add another one of those? I'm not sure. Let's see, 48 times 9. 2, 7, 36. 42. All right, so we're really close to 9. We were probably going to get 8 something. So it's so close that the answer is 51.9. All right. So this again was all over the place. By the way, if you had a problem going back and forth with this, think of this really as if it was a thermometer or a number line on its side. That's really what's going on here. So in other words, if we had a number line that we had 0, first we went negative down, then we came back, right, to here, and then they're basically asking us what is that distance, right? Distance is normally positive. That's why when we took this thing, we did the absolute value of it. All right. So this was a pretty involved question. This was worth 3 points, I believe, in the context of the others. I think the question before it was also worth 3 points. I think I did this in the first section. Yeah. This is part B. I did that in part A. So again, a word question, multi-part problem, taking it a step at a time. This is also involved positive and negative. That's really important. Again, look at it as the number line. And it just involved simple quote, simple arithmetic operations. All right, guys, please like and subscribe. Please, set notifications so you can see what's going on. And have a nice day.